Okay, hopefully you're starting to feel more and more comfortable with factoring, but the one that we're working on today is hopefully something you'll recognize and it'll make it easier for you. But we'll see. Let's see. So it starts off the worksheet with the regular X factoring. This is not the special kind of factoring. So let's just go ahead and recognize like, oh, this is a trinomial. We can do X factoring. What times what makes negative 21 and adds up to 4? So we think 3 and 7, which one's going to get the negative? To make this a positive in the middle, we're going to want 7 minus 3. So x minus 3, x plus 7 in any order. Next one has a negative 24 in the top with a negative 10 in the bottom. What times what makes 24? Hopefully you're thinking, so 3 and 8 makes 11. Hopefully you're thinking 2 and 12. And then which one's going to get the negative to make this negative in the middle? So that is a 2 minus 12. Okay, let's use the same colors. Next one is what times what makes 15 and subtracts to negative 8. Hopefully you're thinking 3 and 5. What signs would they get? They both need to be negative. Now, starting with this next row, hopefully you recognize those perfect square trinomials from way back when we were doing the diagrams. What times what equals 16 and adds up to 8? 4 times 4 is 16. So we write out those factors. Notice it's a letter M. M plus 4, M plus 4. You could write this as M plus 4 squared because it is a perfect square trinomial. What times what is 25? What signs do we want? And then we could write this as x minus 5 times x minus 5, or just simplified as x minus 5 squared. What times what makes 64 and adds up to negative 16? Hopefully you're thinking 8 and 8. What signs do they get? So here I go, t minus 8, t minus 8, or t minus 8 squared. Now starting down here, this is that special kind of factoring, this whole row, meaning when I recognize that there's a perfect square in the front and a perfect square in the back, we could say that this is just y times y at the front, and this is just 7 times 7 in the back. So why is there no middle term? Because there's 1 plus and 1 minus, which makes the middle term cancel out. Same thing for this. This could be an x times x. This could be a 9 times 9. There's no middle term because it's 1 plus and 1 minus. This one's a z times a z, a 10 times a 10. So we get z and 10, z and 10, 1 plus, 1 minus. What are those called? That's called the difference of two squares. And I hope you recognize that factoring because that makes it really fast to do the 1 plus 1 minus thing. This right here is a 0, is a 10. Let's redo that. Okay. Now getting to these last two rows, these are the big mamas. These are the ones that you have to do the x and the t on because there's a coefficient larger than 1, or you have to do backwards box on. So 3 times 6, that makes 18 in the top, 11 in the bottom. What times what makes 18? 2 times 9, which adds up to 11. But we need the x as well because of the 3x in front. So this factor is already reduced, 3x plus 2. And this factor back here, sorry guys, I wrote the 11 instead of the 9. I'm like, what'd I do wrong? Put this 9 right here. And this factor back here, 3x plus 9, can be reduced by dividing this 3 out. So my final two factors here, let me put it in red, are 3x plus 2. That one was already done. And the 3 divides out, leaving me x plus 3. You can double check this to make sure you like it. 3x times x, yep. 2 times 3, yep. And you can do the full FOIL or the full box to see if you like it. But these are my factors. Okay, looking at the next one, do you see the 4 times 5 makes 20? And negative 9 in the bottom. So what times what makes 20 and adds up to negative 9? 4 times 5, they're both going to get a negative. 4t in the top of the t, negative 4 and 5. We're going to reduce these if necessary. 4t minus 4, a 4 can go into both. 4t plus 5 is already done. So here I'm going to be left with final factors of t minus 1, that's the reduced factor, and 4t plus 5. There they are. This next one's going to be negative 30 with a 13 down here. 3 times 10, which signs do I want? Ooh. This one is not it. This is one of those fake outs. Okay, so what else times what else makes 30? Are you okay with 15 and 2? Maybe you thought of those first and you weren't faked out about my 3 and 10. Okay, anyways, which ones do we want to have with a sign? We want 15 minus 2 for a positive 13. So 5p goes in the top. And then we're going to reduce this factor by dividing out 5. We're going to get p plus 3 as the first factor. And the second one, 5p minus 2, is already reduced. Next one up here has a negative 12 with a 1 down here, so that's my 3 times 4. I'm going to want 4 minus 3 to give a positive 1. So I put the 6x in the top, negative 3 and 4 in the bottom, reduce where we can. We see that a 3 goes into both of these, and a 2 goes into both of these, leaving me these as my two factors. Negative 45 goes in the top, 4 goes in the bottom. Do you see that as 9 and 5? Which one's going to get the negative? Reduce where we can. Three goes into both. 5 goes into both. We end up with factors of 5n plus 3 and 3n minus 1. Double check by multiplying that those work, and they do. All right, negative 24 on the top, 10 in the bottom. 8 and 3 don't work, 4 and 6 do. Ooh, this is another fake out. 4 and 6 do not give us the signs we want, so this is the 12 and 2. 12 minus 2 makes 10, so there's my factors. We want the 8m and the 8m up here, the minus 2 and the 12 here. Let's reduce both of these. 2 go into both of these, leaving me 4m minus 1. 4 can go into 8 and 12, leaving me 2m plus 3. Double check by multiplying, negative 3 at the back, 8m squared at the front. There's my factors. Now we're looking at perfect square trinomials. How do I know this? Because this is a perfect square at the front. This is a perfect square at the back. 9r squared would be 3r and 3r. 4 would be 2 and 2. 3 times 2 makes 6r. If I have a 6r from this and a 6r for this, it gives me the 12r doubled middle term. So if you recognize this wonderful special kind of factoring, it's just this. It's the 3r plus 2 squared factors. This becomes the 4m minus 1 squared factors. And this becomes the 2x minus 3 squared factors. Now, what if you don't recognize these as perfect squares, if you don't have this 4 and this 9 in mind? Could you do the x and the t factoring? Or backwards box if you didn't recognize these special factors. All right, the whole last part is the difference of two squares, where we're going to speed through this. This is 2p and 2p and 5 and 5. And we get 1 plus and 1 minus so that there's no middle term. This next one becomes 7 and 1. 1 plus 1 minus because there's no middle term. 4 and 4 is 16. 3 and 3 is 9. 1 plus 1 minus. Pause the video at this point and you try them. See if you can speed through the last ones of these by just doing the what times what for the front and what times what for the back and 1 plus 1 minus. And you probably noticed that the answers are all right here. By the way, sorry, these ones right here were m to the 4th and n squared, so it's 8m squared, 8m squared at the front. Sorry about that. Okay, hopefully you checked all your answers as you went. How'd you do? Are you starting to recognize these special kinds of factoring to save you some time?